Don't cares given as g of xyz is equal to min terms 5 comma 6 and don't care of 1 to 4. So for this function, consider the following expressions and the solutions for g is. So they are asking the solutions for g. So you can take your time and try to provide the answer. So I will also start doing this parallelly. So let us see this. So what we have, let me add some slides. So we have g of xyz is 5 comma 6 and don't care is 1 to 4. So three variable function. So that means this will be your k-map for your three variable function, and the min terms and the terms are x, y, z, y bar, z bar, y bar, z, y, z, and y, z bar, x bar, and x. Okay. So we have 5 and 6 as our min terms 0, 1, 3, 2, 4, 5, 7, 6. 5 and 6 and don't cares are 1 to 4. 1, 2, 4. So these are our don't cares. So let us try to group them. Let us try to see what are the possible groupings. So we can group this two and we can group this two. Okay. So that the answer will become y bar z plus y z bar. This is our first answer we are getting. No need of grouping this because it is already grouped. Okay. So are we getting this solution y bar z plus yz bar? Fourth option we are getting now. Or else we can perform one more type of grouping. We can group this two. Okay. So that means it will become, so instead of following this grouping, I'm following this grouping and this grouping. So the answer what we will get is x y bar plus yz bar. Are we having this? X y bar plus xz bar we are having. So that instead of following this, I can follow this grouping. Instead of red grouping, I am following green grouping, so that my answer becomes xy bar plus xz bar. Okay. So option B is also matching. Okay. Next. So next what I can do is xy bar. So instead of grouping this min terms with my don't cares, I can follow a single grouping. So I can follow a single grouping like this instead of grouping it with any don't cares, so that my answer will become this. So this is my first answer, second answer, and third answer will become x y bar z plus x y z bar. That is my x y z bar plus x y bar z. First option is also matching. So that is 1, 2, and 4. 1, 2, and 4 option B. I'm getting option B. So consider a logic circuit that has 4-bit binary number as an input and one output. The output should be 1 if the input is a prime number greater than 1, or the output should be 0. So for that we need a minimized Boolean function. So that we have a circuit, a black box like this. So for this we have some set of inputs A, B, C, and D. So 4-bit binary as an input and output should be 1. So y should be equal to 1 only if the input is a prime number greater than 1, or else output should be equal to 0. Okay. Y is equal to 1 if it is a prime number greater than 1, and y is equal to 0 if it is a prime number, if it is not a prime number. Okay. So that is our requirement, and we need to find the Boolean expression for y. Try this one. Take some time and try this one. What is your approach? What are you going to do in this question? Yeah, prime numbers only, but how we are going to get our equation for output? We need equation for output y in terms of A, B, C, and D. Okay, so I will also do this parallelly. So I can draw a simple truth table. Okay, where A, B, C, D are my inputs, and this is my decimal equivalent. and this is my output. Okay, so now so what we have, so what are all the prime numbers we have? Decimal equivalent. So greater than 0, what are all the prime numbers? 2, and what else we have? 2, 5, 7, 11, and 13. These are our prime numbers greater than 0. Yes, exactly. And we are going to write down the equivalent of them: 0, 0, 1, 0, 0, 1, 0, 1, 0, triple 1, 1, 1, 0, 1. Okay, so in these cases the output will be equal to 1, and remaining all the cases output will be equal to 0. That is, for 0, 0, 0, 0, output will be equal to 0, and remaining numbers output will be equal to 0. For all the remaining numbers the output will be equal to 0. So these are our minterms. Can I say these are our minterms? Sorry, 3 is also a prime number. Yes, 0, 0, 1, 1. Output is 1. Okay. In the question they have asked greater than 0, no? Greater than 1. In the question they have asked greater than 1. Okay. So that's why we are taking from 2. So 2, 3, 5, 7, 11, 13, and remaining are all 0. Okay. So these are my main terms. So what are my main terms I'm getting here? The main terms I'm getting here are M2, M3, M5, M7, M11, and M13. These are my midterms. Okay. So just simply draw a K-map for this 4 variable K-map. A, B, C, D, C bar, D bar, C bar, D, C, D, C, D bar, A bar, B bar, A bar, B, A, B, and A, B bar. 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15, 14. And we are going to fill up all our minterms here. So what are the minterms? 2, 3, 5, 7, 11, 13. 2, 3, 5, 7, 11, 13. Okay. And we need to group them. So what are we getting if we are grouping them? So I can group this two, and I can group this two, and what else I can group? This two I can group, and this I can group with the corner term. Shall I consider this two grouping 3 and 7? Shall I do this grouping also? Yes or no? Please let me know in the chat box. Shall I do 3 and 7 grouping also? No. Why? Because it will become a redundant term. Okay, redundant implicant, it will become a redundant implicant. Okay. So what is our final answer we are getting? So we are getting A bar B bar into C, A bar B bar into C, plus what is common here? CD is common, and B bar, B bar CD, plus A bar B plus A bar B into D, plus what is common here? B C bar D, B C bar D. So this is our output expression Y. So Y is equal to, here we can fill up, Y is equal to A bar BC plus B bar CD plus A bar BD plus BC bar D. Next, try this one. So if certain application, in a certain application, 4 inputs A, B, C, D are fed to a logic circuit producing an output which operates a relay. So the relay turns on when f of A, B, C, D is equal to 1 for the following states of inputs: 0, 0, 0, 0, 0, 1, 0, and 5, 6, and 13, and 14. Okay. States 1, 0, 0, 1, 0, 0 do not occur, and for remaining states the relay is off. The minimized Boolean expression is. Yeah, this is single question. Yes. So try to answer this. So a certain application, four inputs fed to a logic circuit producing output which operates a relay. So the relay turns on when the f of ABCD is equal to 1. So we need to find the expression for f. So again, what is the approach we are going to use here? The same approach we have applied for the prime numbers. So we are going to consider only those minterms whose output is becoming 1, for those whose output is becoming 1. So let me draw the truth table for this: A, B, C, D, and my output Y. Okay. So what are all the combinations I have? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 0. So 0, 0, 1, 0, and 1. Okay. Now, for what inputs your output will become 1? So the inputs are 0, 2, and 5. 0, 2, 5. Okay. 0, 2, 5, and 6, and 1, 1, 0, 1. And what else we have? 1, 1, 0, 1, and triple 1, 0, and triple 1, 0. Okay. And remaining what else we have? 1 triple 0 and 1 double 0 1 should not occur. 1 triple 0, there is 1 triple 0 1 triple 0, and 1 double 0 1 should not occur. 1 double 0 1 should not occur, so I am taking them as don't cares, and remaining are all zeros. Okay. For all these conditions, I am going to get my output as 0. Now what are all the min terms I have? So min terms are simply sigma m. I'll write down here. So the min terms which I can write directly from the question itself. So the min terms are 0, 2, and 5, 6, 13, and 14. So these are my min terms plus don't care of 9, 8, and 9. Okay. So these are my min terms and these are my don't care. So I can form a key map and I can solve it. Okay. So I'll draw the key map here. A, B, C, D, C bar, D bar, C bar, D. So 0, 2, 5, 6, 13, 14. 0, 2, 5, 6, 13, 14, and don't cares are 8 and 9. 8 and 9. Yes. So these are my min terms and my don't care. Now if I group this, then I can form this 2, and I can form this 2 pair and this 2 pair. So shall I do this grouping? 8 and 9, shall I group them? Okay, option 4. Okay, nice. So should I group this 2 don't cares? Is it necessary? No, I should not. Okay, if necessary only you should involve don't cares into grouping, or else you should not. Okay. So what is the common term here? A bar, B bar, and D bar, plus C bar, D, B, plus B, C, D bar. Okay. What is the option you're getting? Option B. Exactly. So is it clear for everyone? Any doubts or any queries? So try this one. So there are four Boolean variables: x1, x2, x3, and x4. The following functions are defined on sets of them. F of x3, x2, x1 is 3, 4, 5. Min terms are 3, 4, 5. And g of x4, x3, x2, sorry, x4, x3, x2 is 1, 6, 7. And x4, x3, x1 is f into g. H function is f into g. We are multiplying f and g. Then we want h, x4, x3, x2, x1, which is a function of x4, x3, x2, and x1. First try to find out h, then we'll find out f2. First trying to find out h. This parallelly. So function, function x3, x2, x1, x3, x2, x1. The min terms are 3, 4, 5. And here x4, x3, x2, x4, x3, x2. The min terms which I am having here are 1, 6, 7. Now h, x4, x3, x1, x4, x3, x1. I'm having them as f into g. I need to find f into g. So first of all, I will find out the equation for my f. So I can use K-map or I can directly solve, your wish. Okay, you can use a K-map or you can directly solve them. It's up to you. So this is x3, x2, x1, x2 bar, x1 bar, x2 bar, x1, x2, x1. 3, 4, 5. So I'm going to group this two, and this is a single group. So my answer for my f, which is a function of x3, x2, x1, is simply I'm getting x3, x2 bar plus, this is x2, this is x1, x3, x2 bar plus x3 bar, x2, x1. So this is my answer for f of x3, x2, x1. Now what is g if I am getting? I will draw the K-map for g. Which is a function of x4, x3, x2, x4, x3, x2. So x3 bar, x2 bar, x3 bar, x2, x3, x2, and x3, x2 bar, x4 bar, and x4. So 1, 6, and 7. 1, 6, and 7. So I can group these two and I will single this. So the equation for your g will become x4 bar, x3 bar, x2, x4 bar, x3 bar, x2 plus x4, x3 plus x4 into x3. So this is my equation for f and this is my equation for g. Okay. Now for getting my equation of h, I need to multiply these two equations. Then I will get the equation for my h. So h is equal to f dot g. So which is nothing but x3, x2 bar plus x3 bar, x2, x1 into x4 bar, x3 bar, x2 plus x4, x3. So now I need to multiply these two equations. So if I multiply these two equations, then what I'm going to get is x4 bar okay, I need to solve it. X4 bar x3 into x3 bar is 0. Okay, so I will get 0 simply. So plus x4 into x3, x4, x3, x2 bar, x4, x3, x2 bar plus, if I see here, then x3 bar, x4 bar, x3 bar, x2, x1, x2, x1. So this term is made to 0. Okay, we have only two terms. Anyone getting the answer? Okay, I will solve this. So I'm getting x4, x3, x2 bar plus x4 bar, x3 bar, x2, x1. Now what I can do is, if I take x4, x3, or what I can do. So if I take x4, x3, x2 bar, can I take anything missing? Okay, so what is that they're asking? They're asking equation of h in terms of x4, x3, and x1. Okay, okay. So in this term, x1 is missing. So in this term, x1 is missing. What is the answer they are asking? So they are asking answer h in terms of x4, x3, x1. x4, x3, and x1. So here x1 is missing. Okay, so we are going to uh, convert this into canonical form. So how to convert this into canonical form? So simply we can convert this. Wait a minute. This is x4. Sorry, the answer they are asking in x4, x3, x2, x1. Here there is a mistake here. The answer should be in h of x4, x3, x2, and x1. Okay. So they are asking in this term. So that is nothing but x4, x3, x2 bar into x1 plus x1 bar plus x4 bar, x3 bar, x2, and x1. Okay. So that means our answer will become x4, x3, x2 bar, x1 plus x4, x3, x2 bar, x1 bar plus this one. Okay. Now what is the minterm here? It is nothing but 1101, that is 13. And what is the minterm here? 12. So 12 and 13. 12 and 13. This is option C. And this is, I have missed it. Okay, okay, sorry. 12 and this one is 3. So it's option A, not option C. It's option. Okay, I've missed it. Yes. Now is it clear? Yes. So the minimum function that can detect a divisible by 38421 BCD code is given by. So that means we have again a black box and we have four inputs which is given to this black box A, B, C, D, and the given inputs are BCD code, BCD representation, and our output should be 1 if the given input is divisible by 3, 0 if it is input is not divisible by 3. Try this one. Yes, can anyone tell me what are the minterms we are getting for this? What are the minterms here we are getting? Exactly. So a minimum function that can detect divisible by 3, we are getting 3, 6, and 9. Yes. So just use it in the key map and solve it and let me know. Is it 369 or is it 0369? 0 is also divisible by 3 now. Okay. The minterms are 0369, not 369. So if I put this in key map, it is a 4 variable function now. D8, D4, D2, D1. and this is D8 bar, D4 bar, and if I perform the grouping, so what are the minimums? 0, 3, 6, and 9. So and do we get any don't cares here? Can it be option? Here there is a here we should be careful that input is a BCD code now. Input is a BCD code, so there will be invalid codes also now. That means from 10, 11, 12, 13, 14, 15. So these are our don't cares. Okay, so 10, 11, 12, 13, 14, 15 are our don't cares. So if I am giving it to my inputs, then there will be considered, these minterms will be considered as don't cares. Okay, so I will fill this up: 10, 11, 12, 13, 14, 15. Okay, so I will make a group of quad here, and I can group this two, and this will be grouped with this one, and finally this one is left out. So my final answer will be D8 D1 plus D4 D2 D1 bar plus D4 bar D2 D1 plus D8 bar D4 bar D2 bar D1 bar. So this is my final answer. So this simplified expression you can try it out. This is simple only. Okay, this you can try it as an assignment. This also you can try it out. These are simple questions only, just solving them using the down case and minterms. This is also simple question only, just taking the minterms and don't cares. You can try this out. So this one also, okay, try this one: a plus b into b plus c bar into a plus c. They're asking the max terms. So can we take the max terms directly from this function? Can we take out the max terms directly from this function? No, we cannot take, because it is not in a standard standard form. Okay. Now how to convert this? We need to convert this into canonical form to get the max terms. Okay. So we can convert this into canonical form for getting the max terms. Okay. So how to convert this into canonical form? Okay. So this one is also simple. Just convert this into canonical form and take out the max terms. Okay. So this one also you can take it for assignment. Yes, try this one. A switching circuit has two control inputs C1 and C2, two data inputs X1 and X2, and one output Z. So the circuit performs one of the logic operations and or equivalence or XOR on the two data inputs. So if C1 and C2 is 0 0, then my output is OR function. So this is my black box, and this will have two control inputs C1 and C2, and I will have basically two inputs X1 and X2. So depending upon this will be my Y. So Y will be performed with OR operation if C1 and C2 are 0, and Y will be performed with XOR operation if C1 and C2 are 0 1, and Y will be performed with AND operation if C1 and C2 are 1 0, so on. Okay. Then they are asking for the expression Y, or they have given Z. Okay. So they are asking for the expression Z. Think about this and try to come with an approach. Let me show you. So we have two control inputs C1, C2, and we are going to take our inputs X1 and X2. Okay. So total four variable means how many min terms? So total 0, 0, 0 to 1, 1, 1, 1. Okay. So these are our total combinations. So 0, 0, 0, 1, 1, 0, 1, 1, 0, 0. Okay, we need to have all the combinations, right? Okay, for okay. Yeah, so up to, yeah, this is correct only, 0011 and 01 again we are going to check from here to 0111. Okay, so total like this we have 16 combinations. Okay, and from the 16 combinations, if your control input is 0, then you are going to perform OR operations. So your output is 0 1 1 1. Okay, next, if your control input is 0 1, then you are going to perform XOR operation. That is, your output will be equal to 0 1 1 0. And next, you are going to find out equivalence. For equivalence, what operation we are going to do? XOR or XNOR? For finding out equivalence, that is both inputs are equal, what we are going to do? XOR or XNOR? We are going to perform XNOR operation. Exactly. So here we will have next set of min terms are 1 1, sorry, 1001. Okay, next we will have sorry, next AND gate now, so that's why it is not 1 1 1001, it is 0001. Okay, followed by 1001. Okay, let me write down this clearly. So it is C1 C2 X1 X2, and this is your output. Okay, so 0 0 0 0 1 1 0 1 1. This is one set. This is same up to here, it will be 0, and this will be 0 1, and this will be 1 0, and next set will be 1 1. C1 C2 X1 X2. So this will be 1 1 up to here, again 0 0 0 1 1 0 1. If it is 0, we are going to perform OR operation, 0 1 1 1, and here we are going to perform XOR operation of XOR operation, 0 1 1 0. Next we are going to perform AND operation. Next we are going to perform XNOR operation. Okay, OR operation, XOR operation, AND operation, and XNOR operation. Here we are going to perform XNOR operation, 1 0 0 1. So from this we can easily take out our min terms and we can form the equation for your output y. Is this clear? Yes or no? Please let me know in the chat box. Simply we can take out the min terms where your output is becoming 1. Those min terms we can consider and follow a k-map, and we can solve that equation. Okay. Yes. So I think you can do that, right? And this question, next we have two more questions. I will give this questions as your assignment. So these are also same. These are also same as we have discussed it as our previous problems, right? These are also simple only. You can try them out and we will discuss it in our next session.